this first section of Chapter 5 that I had asked you guys to do? Okay. Everybody should also have in front of them one of these basic trig identities handouts. We'll talk about what you'll get on the test when it gets a little bit closer. But what I would like for you guys what I'd like to do here today is to go through this first assignment, because I think it's a really important one, kind of together. So you can look at your homework, or you can look at this identity sheet, which you'll probably need to use throughout, and we'll kind of piece through these problems kind of together as a group. Okay? So I think it would be really good for all of us if you guys try to, like, I'll ask some questions, but try to participate. Like, look at the identity sheet, try to figure out, like, what to use next. If I decide to use something that you're not sure why I use that, or if you could do something different, please stop me and ask. Please stop me and ask. I'd be happy to, like, spend some more time or to try it a different way and see if it works or any of those sorts of things. This chapter in particular is very much about, like, you need to build some experience. You need to kind of play around with things to develop some intuition. So that's really what I have budgeted for today, is to just, like, have you guys more or less direct what we think we should do. If I think there's an obvious better way that nobody suggested, I will surely point that out and talk about what I saw in order to kind of see that better way. But I think that you guys kind of following your instincts and kind of honing in on your instinct, I think would be the most valuable here. And if somebody's doing something decidedly wrong, like, I'll stop you and, like, explain why, like, what you're trying to do is not okay or whatever. And I don't want anybody to feel like they're being picked on for that or whatever. I'm just trying to give appropriate feedback and be, like, really clear about whether something's okay to do or not okay to do, and why or why not. Okay? Okay. So, let's look at number 1. Here we're asked to find the exact value without using a calculator, and we're asked to use identities rather than a reference triangle. So, which identity would I want to start with here? So, when I say an identity, like one of the ones from the sheet, so you want to use P1, okay? You could do that. So P1 says sine squared theta plus cosine squared theta is equal to 1. So what can I do here? And then I would, okay. And in the goal, what am I trying to do here, though? Good, solve for sine, right? Okay. Yeah. So in this problem, there's actually a couple of different starting points you could have taken. And if when we're finished with this one, if we'd like to talk about some other possible starting routes, we can do that. So the reason that the Pythagorean identity is going to be particularly useful to us here is it's going to create a way to relate like sine and cosine together, because I know that sine and cosine, well, sine over cosine is tangent, so it's kind of going to include all three of the trig functions that I'm interested in. So that's kind of why I'm doing that. So, you know, it has just sine and cosine, so I'm able to isolate the sine, and then I can use what I know about tangent to kind of sort the rest of it out. Does that help at all, Liz? Okay. So usually for these ones, you're going to want to start with one of the Pythagorean identities. In general, is usually a good tact. Okay. So if I continue on, I get that sine theta is equal to plus or minus the square root of 15 over 4, right? Now, how am I going to decide whether I should have the plus or the minus here? So tangent is less than 0, though, in two places, right? Here and here. Well, if cosine is positive, yeah. Yeah. So we need cosine to be positive and tan to be negative, right? Actually, let's do those in two different colors. So if I get rid of that stuff, cosine is positive here and here. Tangent is negative here and here. So the quadrant that we're in is definitely the fourth quadrant, right? Which tells us sine should be what? Negative. Alternatively, how could I have used an identity to make that same conclusion? I know that tangent theta is equal to sine theta over cosine theta, right? If that's less than 0 and cosine is positive, sine must be negative, right? Because that's the only way a fraction is going to turn into a negative value, is if either the numerator or the denominator is negative. That's probably a little bit easier than sorting out the quadrants, but not wrong to use the quadrants. Joanna? You're talking about what I've written right here? If you wrote what I wrote right there, that would be enough to justify. Yeah. That would be enough for me to justify why that's negative. Okay. Another way you could have approached this is you could have used, what would I say, P3. Let's look at what if we had used P3. That's okay. Yep.
Okay, thank you.
All right. So what am I going to use here? So I know that cosine and secant are related because they are reciprocals. So what can I sub into the value for secant? 4. So I can say tan squared theta is 16, or that tan theta is plus or minus, I'm sorry, not 16, 15. My goodness gracious. So that's plus or minus the square root of 15. But I know that because tangent is negative, it's just negative square root 15. Correct? And then I know that this is equal to sine theta over cosine theta. And if cosine theta is 1/4, if I multiply both sides by 1/4, I get that sine theta is negative 15 over 4, or negative root 15 over 4. So you could have done it that way as well. I think that way is the way that I would have chose to do it because I related directly tangent, sine and cosine together in that same problem. But the other ways that we did it were perfectly acceptable. Any questions about number 1 here? Okay. Which one, if we look at number 2, which identity would we want to start with here? Yeah, so there's lots of options here. I would probably use P2 if it were me, but there's P1 would certainly be acceptable. You can certainly use that and still work things out. You have to be a little bit sneakier about figuring out the sign at the end. If you chose to use P1, P2, it's a little bit easier to figure out what to do with the sign. So that's the reason why I'm going to pick that. The reason I know it's going to be a little bit easier to figure out what to do with the sign is because cotangent appears in that identity all by its lonesome. I don't have to do any interpretation of what that means through some other identity. It's sitting right there for me. Is everybody okay with that reasoning? So if I do that, I'm going to get 1 plus cotangent squared theta equals 9, or that cotangent theta is equal to plus or minus 2 root 2. Now, I did a lot of simplifying there all in one step. Is everybody okay with that? I subtracted 1 from both sides, took the square root, and simplified the radical all in that one step. Take a moment and process that. And if you need to write out the individual steps, that's okay. Not a big deal. But sometimes I'm just going to say the steps aloud and maybe not write them all down. You guys get it? Sure. Because the square root of 8 is 2 root 2, right? That simplifies down to 2 root 2. Which, again, if you thought about it for a minute, you'd be like, oh, yeah, sure. See? You thought about it for a minute, and you're right there. And since I know cotangent is positive, I know that this is just 2 root 2. And now if I go and I look at my identity sheet, I'm going to look for a value or an identity that relates cotangent directly with secant. Do you guys see any of those that do that? Relates cotangent, that's what we know, with secant. Q2 is the one that you'd want. So that's going to equal cosecant over secant, right? It's given to me in the problem. And now all I have to do is get the secant by itself, right? So I multiply both sides by secant alpha, and then I divide by 2 root 2. And then I'd probably want to rationalize this denominator. By multiplying the top and bottom by root 2. And that would give me the negative 3 square root 2 over 4. So you're going to observe here right away that the better you kind of know these identities, even if I didn't require you to memorize them, like if you know what to look for, it makes these problems go much, much faster, and that things work seem much more obvious if you're already familiar with these identities. So even if you're not required to memorize them, like kind of memorizing them is usually in your best interest. Things tend to go better if you really know these identities. Just because your train of thought doesn't have to get broken while you go back and like search for what it is you're looking for. It's like, oh, I need something with this and this. Okay, it's that one. You know, or at least you know exactly where to go to find it. You know what I mean, guys? So let's look at 3 now. Okay. Let's do 3 both ways, using an identity and then also using a reference triangle, just to kind of see the difference. Okay with that plan? Okay. Which one do you want to start with, the reference triangle or identity? Okay. So I'm going to start by drawing my XY axis. So I have all silly turtles crawl here. Cosine is positive in the first and fourth quadrants. Cotangent is negative, the same places that tangent is negative, which would be the second and fourth quadrant. So what place is my answer in? The fourth quadrant. Okay. So here's my reference triangle that I've drawn in. Notice that when I draw my reference triangle, I'm always drawing it back to the x-axis, never drawing my triangle with a side on the y-axis. Okay. So cosine is adjacent over hypotenuse. So I can use the Pythagorean theorem then to solve for that third side. Oh, that's 9. 7. There we go. So I get that. Now, is this 7 positive or negative? Or square root 7 positive or negative? Negative, because it's in the fourth quadrant. Right? That y coordinate is below the x-axis. So now I can evaluate everything else, right? So like sine of theta would be opposite over hypotenuse. And so on and so forth. Do I have to write down all of them? No, I think once you have this picture, you should be pretty good, right? Sure. I saw so many people writing, I was just kind of pausing before I started. I didn't know if they were writing the rest of the answers down that they were getting or what, but I saw a lot of pencils going, so just kind of pausing. Taking a breath, letting that settle. Yeah. So the green was where cosine was positive, and the blue was where cotangent was negative. I'm sorry, where cotangent was negative. So I tried to color code it there. Yeah, because they're reciprocals. Opposite over hypotenuse. I didn't do all the other 5 of them. I just did one and said, okay, from here you guys can handle it because we have the triangle. You guys ready to do the identities now? Okay. All right. So I'm going to erase this thing right here. I don't think I need any more space than that, though. Okay. So first thing I'm going to do is figure out the value for sine. Because once I have that, I have cosine, I have sine, then I can get tangent, cotangent, secant, cosecant, everything else from it. Everybody agree with that? Because all those other are in some version of sine or cosine or both, right? Okay. So this basically just turns into this problem where I just want to find sine. So the identity that I would use is P3 And I know that secant and cotangent are reciprocals. So I can plug in 4/3 to secant. 4/3 squared is 16/9. And if I subtract 1 from both sides, I get 7/9. And if I square root both sides, I get plus or minus square root 7/3. Everybody's okay there? And tangent and cotangent are reciprocals, right? Everybody agree with that? And I know that cotangent here is negative, so I can say that. Yeah, let's not do that way. Okay. So I decided I wasn't going to use the triangles because I said I wasn't going to use triangles. I was going to use identities. So I was like, oh yeah, I shouldn't do it that way. Okay. Yeah, it was going to be easy, but I said not to use I said I wasn't going to use the triangles. So yeah. Because we already did triangles before, right? All right. Stop talking, please. Cotangent, I know, is cosine over sine. And I know cotangent or cosine is 3/4. So to solve for sine, I'm going to have sine theta equals 3/4 divided by -3 square root 7, which turns into negative square root 7/4. Again, I skipped some algebra there solving, but I just like cross multiplied and then solve for sine. Like it's not tricky. They just have fractions in there, which, oh no. So now that I have an answer for cosine and an answer for sine, I can build everything else out of there, right? So secant we know is 4/3, right? Cosecant we know is -4 over square root 7. You have to rationalize, but whatever, no big deal. Cotangent we figured out along the way as -3 over square root 7. Tangent we also figured out along the way, which is -7 over square root 7/3, and we're done. If they're numbers, you should. If they're numbers, you should. Olivia. Sure. Bella. Sure. So the reason I started with P2 or P3, so you can use multiple identities if you need to. The reason I use P3 is because it involves cosine because of the secant, and it involves tangent or cotangent because of the tangent, right? Yeah, that's basically what I looked for. Well, we don't have unlimited more to go, but we can do a couple more. I do want to do some of the simplifying ones. Yeah, let's do one more of these, and then we'll move on to the other type. Do you guys have a preference between 4, 5, and 6?
Let's do 6.
I think 6 is probably wise. What's weird about 6? So when we say undefined, I know that it's going to be something over 0. Right? Everybody's okay with that? Okay. So this, I know cotangent is x over y. So right away I can tell that y is 0, right? If I go back to the unit circle definition. And x is either going to be 1 or -1. I'm not sure quite yet. Secant is the same as 1 over cosine. So I know that secant is equal to 1 over x, because cosine is just equal to x on the unit circle. When I'm saying x and y, what am I talking about? The ordered pairs of the points on the unit circle? Yes? Like, this point is cosine theta comma sine theta. Right, where that's theta. Right? You guys remember that? So like that's my x and that's my y. So if that's the case, if secant is 1 over x is equal to 1, what's x? 1. So I know x is 1 and y is 0. That's all I need to figure out everything else, right? So sine is equal to 0. Cosine is equal to 1. Tangent is equal to y over x. Cotangent we are given. Secant we're given. So we don't need to worry about either of those. And then cosecant is equal to 1 over y, which is also undefined. This is basically the reference triangle way of doing this. Why did I not draw any single reference triangles on this? There is no triangle, because what angle are we talking, or what point are we talking about? We're talking about that point. How the heck do where's my triangle that I'm going to draw with that? There isn't one. So that's why there's no triangle in this when we did the reference triangle way. We had to go to the unit circle. Okay? Sure. So on the unit circle, I know x coordinate is cosine and y coordinate is sine. I know that tangent is y over x, because it's sine over cosine. So cotangent is x over y. It's the reciprocal, right? So undefined means that I'm dividing by 0. The only points on the unit circle that have 0 is we have a 0 is one of these quadrantal points, where the other coordinate is either 1 or -1. So I know for undefined, I either have to have 1 over 0 or -1 over 0. And since this is cotangent, I know it's x over y, so right away I can tell that y is 0. And x either has to be 1 or -1. I'm not sure which one yet. If I go to the fact that secant is equal to 1, I know secant is the reciprocal of cosine, and if cosine is equal to x, secant is 1 over x. And if 1 over x is equal to 1, then x is just 1, right? It can't be negative 1. So that's what I needed. So my x is 1 and my y is 0, and then I filled out the rest of the from there. How would I do this with an identities? I'm not positive right off the bat. Actually, I think this would be quite easy. Never mind. So let's say we start with P3. So if I do that, I have tan squared plus 1 is equal to 1, right? So right away, I get that tan is 0. Okay with that? And that immediately gives me that cotangent then is undefined. You good with that? Okay. And if tan is 0, if tan is sine over cosine, that tells me immediately that sine is 0 also. Because the only way a fraction is 0 is if its numerator is 0. Which also then tells me that cosecant is definitely undefined. Everybody okay there? And then because secant is equal to 1, I know cosine is its reciprocal, so that's also equal to 1. And that's everything. So the identities I used there that was actually really easy. You had to be a little bit sneaky about your interpretation. Do we need to go through that one more time? You guys seem frustrated. Was it too? Okay. Okay. Let's go back. Hey. No. It's okay to look. It's okay to complain. It's okay to tell me you don't understand. It's okay to be frustrated. Like, take me back on this problem to where I lost you, and we'll go start from there. Okay. So picking P3 then.
Okay, yeah.
Perfect. Okay. So this is why I picked P3. Because I knew secant was equal to 1. So I looked for a Pythagorean identity involving secant. That is P3.
Is there a reason you were like, I want to pick a Pythagorean identity rather than like a cofunction and odd?
So the cofunction and odd and even ones are almost always worthless.
Okay.
So in general, I'm not going to waste a lot of time looking at those. They're very rarely used. And they're super obvious when you're going to need them. So like they're usually not ones that come up very often. Your main tools are going to be those first, the reciprocal quotient Pythagorean. Okay? So, good questions then. I'm glad to help narrow this down. So, there's no reason that you couldn't have started instead of with P3 by looking at R5. R5 is just that secant is equal to 1 over cosine. Or cosine is equal to 1 over secant. You could have done R2 as well. To immediately give you that cosine is also equal to 1. Right? That should make sense, right? You could have done that first. That's perfectly reasonable. Now, armed with these two things, what I want to do is find another identity that involves secant and cosine separately, probably. So I would look at P3 for the secant and P1 for cosine. If I plug 1 in for secant into P3, I immediately get that tangent is equal to 0. Right? Because I have tan squared plus 1 is equal to 1. If I did the same thing into P1, I'd immediately get that sine is equal to 0. because I get sine squared plus 1 is equal to 1. Right? And then using this, I can use, where is it? R4 to say cosecant is 1 over 0, which is undefined. And similarly, from here, I used R6 to say that cotangent is 1 over 0 or undefined. Undefined? Raul, of course. Olivia, does you feel any better?
Yeah, it does feel
Okay. Okay. Now, real talk here, folks. Of the problems here that we've done so far, the ones I'm most interested in you being able to do are these ones here. The 7 through 14. Some of them are quite easy. Some of them are a little bit challenging. But these are the ones that I think have long-term more value. And I'm personally more interested in you being able to do these ones. Okay. So simplifying these. Are the Pythagoreans really an option here for number 7? Not at all. Why not? There's nothing squared. There's nothing squared, and there's no 1. There's not like a plus 1 or something anywhere in here, right? So the Pythagoreans are pretty much out. Worthless for this problem. What I do like for this problem is the quotient, because I can see that I can rewrite cotangent with a sign in it using one of the quotient identities. Which quotient identity would I want? Q2. Which version of it? The first part or the second part? First part. Oops. Everybody okay there? Then what can happen? Can we do any better than that?
No.
Single trig function, that's as good as it gets.
I feel like we should have a test with ones like 7.
There'll probably be one just like 7 on the test. Gabe. So the problem, all I did was replace cotangent with this. The reason I did that is because, stop talking please, is I'm trying to get this from 2 factors, cotangent times sine, to 1 factor. Typically the way that's going to happen is something's going to cancel out. So I looked for a way to rewrite cotangent so that it had sines in it, because there's not a good way to rewrite sine so it has cotangents in it. Go look at the identity list. Is there anything involving sine all by itself and then cotangent? There is not. So that's why. Does that feel okay? All right. Let's go to 8 now. Jackie, what's up? Oh, I didn't. That's part of the problem. The times sine?
Oh, got it.
Yeah, yeah. Okay. Good. Let's look at 8 now. Okay. 8. What are you going to need to use? What's super obvious? The cofunctions. Because of that stupid pi over 2 in there. Let's get rid of that first off. what should I turn that into? Cotangent. Everybody's okay there. So I use C6 there to do that, right? Okay. And that's right. How did I get that? Look at C6. So it just allowed me to replace the tan pi minus or pi over 2 minus x with cotangent. Well, let's see, is there an algebra thing? There's an algebra thing screaming at me. I can do that, right? Just do a little reducing. So I'll just write reduce there, because that's what I did. Okay? You're not required to write those over the equal sign. I'm just doing it for you guys right now so you can see what I did. Yeah. All right. What do you want to do now? Nope, there's still a little bit more we can do. Okay? So, what identities are you going to use here then?
Don't answer that.
What about Q?
Okay, we can use Q2. That's going to rewrite the numerator as okay, and then what are we going to use in the denominator? Why did I want to do that? Everything is now in terms of sine and cosine. So now, let's do a little bit of algebra here. What are we really doing here? Good.
No way. Or this side.
Oh. Okay. I just div, divided. That's all I did. Because I did the division, right? Multiplied by the reciprocal to divide the two fractions. Okay? We ready to move on to the next one? Yeah. This stuff I am writing just for you guys right now. Just for us. I don't care if you do that or not. Let's look at 9. All right. 9. Let's look at 9. Okay. You need a hint?
Wait,
Yes.
you were picking that I don't know.
Oh,
Wait.
no,
I want to try P1.
Okay. How are we using P1 though? Because this is... So you could think about it two ways here, folks. We have a 1 there, right? Oops, those are X's. So you could think about it that way.
Why would you think of that?
Is that using P1?
Yeah, according to P1, 1 is equal to sine squared plus cosine squared, right?
Yeah. Oh.
So you could do that, or you could say sine squared plus cosine squared is equal to 1. If I subtract cosine squared from both sides, I could use that version of P1. Either way of thinking about it is fine, because what do we end up with after we use P1? Sine squared over sine, right? Either way of approach or either way of using P1 is fine. We end up with the same thing, right? Good. Let's go to 10. Good.
Okay, are we doing number 10?
Yeah.
Okay. Wait, 10 I think is really hard. 10 is alright. No, it's not. Okay. Alright. So, you could.
Do we want to use any of the R's?
In fact, Gabe, that's probably what I would... Okay, so when I look at this, immediately what is out? What I know am I not going to need?
Co-function.
Cofunction, good. What else? Odd even, good. What else? Pythagoreans. Why are those out? But using the Pythagorean in the denominator, you're going to get a sum in the denominator. That makes life way worse, right? That makes life worse. I would not want to go near doing that. You could. They're not out of bounds, but they're just not going to be helpful. So, I would either use...
Reciprocal or quotient?
Yes. That's where I'm going to live. Everybody okay with that?
Yes, sir.
So I would in fact use the, I'm going to do both here. So I'm going to use Q1 on the tangents, and then I'm going to use, what am I going to use here? I'm going to use R4, and I'm going to, you could use Q1 and use the second part of it. It's fine. It doesn't make it any easier to deal with. And I'm going to also use R5. Yeah, of course. Yeah, so I used quotient 1, really, Q1 twice.
So are we using R for phi? Are we using all that strictly in terms of sine and cosine?
Okay, now let's divide these fractions. Pretty okay there. No, I'm not thinking about it that, I mean, you could, yes, but I'm not going to think about it that way. Look at the numerator. I'm not simplifying, because if I do that, I'm going to lose the common denominator. We'll get. I'll show you in a moment. You have the right idea. You have the right idea. Okay. So I didn't really know where I was going to go on this, but now I see it. And it could have been a little bit easier than what I did here, but it's still going to be pretty easy. No. So here's what I see. I see a greatest common factor. Right? Squared. I factored out a greatest common factor of sine over cosine. And what is this? That's P3. That is, or P1. That's exactly 1. So I have then just sine over cosine, which is tangent. Shh. There's too much shouting to answer the questions. Yes, Joanna? Please. So, just to point out to you guys, the easier route than what we did is, now that I've seen this, I would take the tangent out in the beginning